how a master journeyman bends a 3-point saddle bra.
What's up, you whack hacks? I'm gonna show you rookies how to do a 3-point saddle with 3/4 EMT in between 2 metal boxes. First thing you're gonna wanna do is get the center of your obstruction. Go ahead and measure down, it's 19 3/4. And that's gonna only be the first part of the bend, because we gotta make sure that we add the shrinkage, right? And since we have a 4-inch obstruction and the shrinkage is 3/16 per inch, we gotta add another 3/4, which is gonna give us a total of 20.5, the center line of the pipe. So take your stick of 3/4 EMT, go ahead and mark it, and you're gonna go 2.5 inches each side per inch. 4 times 2.5 is 10. Grab your 3/4 bender, and first bend we're gonna do is that center notch to the 45 degrees. As a matter of fact, that's the only reason why you'd use that notch. Once you got it there, go ahead and flip it up, rotate it, and your outside marks are going to be on the arrow down to the 22. You always need the shoe bender to be facing towards the center. Once you've got that, flip it over again, make sure it's facing the center, and go down to the 22. Once you've completed your bends, go ahead and look down the side. It's nice and neat. Mark it at the bottom, cut it off, ream it out, do the finger test, throw it up against the wall. There you go. And I put some box offsets on it. If you need those, look at my other videos. What's up, you whack hack? Today I'm going to show you how to hook up a single pull switch with two 14-2 wires. Your power coming in, your switch leg going out to the light. We're going to score these ones before we put them into the box. You run the wires in the same hole, make sure you put the 14-2 at the power closest to the stud. It's going to require you to support this within 8 inches. Them cables inside a 1/4 inch. There are 2 sets of 14-2. Side we have power, on the right side we have the switch leg. A curly Q in that guy. A lot of switches don't require neutral. We're just going to go ahead and make those up and cap them off. To start the equipment grounding conductors, go ahead and get a fist and a thumb. Use a piece of that extra wire that you just cut off. Put a wire nut on them, tuck them in, and here's your pigtail for your switch. A few twists in the back with your equipment grounding conductors so it keeps the wires nice and straight. Here's your single pull switch. Let's go ahead and wire it up to these wires. Hook up your equipment grounding conductor to the ground terminal. Torque it down. Rotate it over. This switch, you can hook them up however you want. I always hook up the power up to the bottom. The switch legs are going to go up to the top. Torque them down. If I ever troubleshoot my own switches, I know power's on bottom and switch legs on top. Bang! What's up, you whack hacks? Here I have a lighting box where I brought 14-2 power coming into on the black and the white. The white's just going to be your neutral, right? And then I brought a 14-3 coming down to the first 3-way switch. That's going to have your black for your power, your red for your switch leg, and then your white's just going to be your average neutral. It's going to stop right here, right? Your noodle. The code is going to require neutral at one of your boxes. Since we can see all the switches, all we need to do is have it at one box, so it's going to stop here. Your switch leg is going to stop here. It's going to make up to your 3-way switch in this box. So we have a dead-end 3-way, even though we have a 4-way in the center. We're going to have this dead-end 3-way, so we have to have power over on this side. So what do we got to do? We got to re-identify that white on this 14-3, jumping over to this 4-way, which the black and the reds are going to be your travelers, and then do the exact same thing over here. Black and red travelers, white's going to be your power. It's going to jump over to this dead-end 3-way, meaning this 3-way doesn't have a neutral. This is how you see a lot of basements rough when they bring power into the first box from the home run out into the breaker box, and then they'll carry that power all the way through each light until it gets to the switch. You guys make sure you stay locked in and hit that follow button, like this video, and leave a comment below. Watch out for more videos because we're going to trim this guy out next. Let's go. Where in the code does it require GFCI and AFCI for a dishwasher? You know I'm rocking the 2020. And jump to page 64. And in dwelling units, all 120-volt single-phase 1520-amp branch circuit supplying outlets or devices installed in dwelling unit kitchens. And I would say most dishwashers are installed in kitchens. And I would normally tell you to go to 210.8 dwelling units, 7 sinks where receptacles are installed within 6 feet from the inside edge of the bowl of the sink. And that very well could be the place, but let's go to 422, page 287. You're going to see 422.5 GFCI protection for personnel. Appliance identified in 422.5A1 through A7 rated 150 volts or less to ground and 60 amperes or less single or 3-phase. Shall be provided with Class A GFCI. Protection for personnel. Multiple Class A GFCI devices shall be permitted but shall not be required. And let's go down the list. 7. Ding, ding. And you can't put this receptacle in a place that's not readily accessible. So that's why I do it from the breaker, guys. Bang!